Hello engineers, welcome to the sixth lecture of analog fundamental. We are going slowly in the analog fundamentals. Okay, so firstly we will cover network. Of course, the network is very important as an analog fundamental for that. And once you know the network, you can analyze the analog circuit very easily because you have a capability to understand about the voltage, resistor, capacitor, how is current is flowing from one path to another path, what is the voltage here, how can we decide that the power dissipation across this, and how can you decide that RC delay and IR drop. So they are very important topics in analog circuit design. So that's why we are continue this subject. Okay, so till now we discuss about the network and circuit, and then we discuss about the resistor, capacitor, inductor, and how it will be effect in VLSI domain. And then we discuss about that node, branch, loop, how you can use a MOSFET as a resistor, how can we behave MOSFET is act like a capacitor, and how can we make that inductor from the MOSFET. Of course we use the op amp for that because we cannot design the MOSFET cannot behave like an inductor. Okay, so this is the way. And then we discuss about that ideal voltage source, practical voltage source, independent source, dependent source. Okay, the dependent source is very important because this is the heart of the analog circuit. If you know the dependent source, you can analyze what is happening in the amplifier, what is happening in the current sensing, what is happening in the ADC, what is happening in the DAC, because this will help to understand every non-linear model to linear model. So dependent source, we have at four types of dependent sources: that voltage control voltage source, voltage control current source, current control current source, current control voltage source. Everyone have a every dependent source have own capability. And then we discuss about that simple Ohm's law, KCL and KVL. These are the basic law, and that will decide all the networks part, because by this only, if you know that KCL and KVL and Ohm's law, you can solve any circuit. We have a lot of way that we are using nodal, we are using mesh, we can use a superposition theorem, we can use a Thevenin theorem, we can use a Norton theorem, we can use any theorems, or we can use a basic fundas to determining the voltage and current through the circuit. But the fundamental is KCL, KVL and Ohm's law only. So now KCL we discussed that the algebraic, the entering current and in any node is equal to that outgoing current, or you can say that in any node the entering charge is equal to leaving charge. There is no any stay charge present on the node. That is called the KCL is working on the principle of charge conservation. Similarly, in KVL, the algebraic sum of voltage in a loop is equal to 0. The algebraic means that the direction plus minus. Whenever the current is moving, if you are assuming that current is moving from left side to right side, and if the element is passive, what is the meaning of passive? The power absorbing element, like resistor, power absorbing, it defined in terms of heat. Okay, the resistor, capacitor, inductor, they are the power absorbing element. And if the current is entering there, so the first terminal of that is positive and the leaving terminal is negative. It is always true. And whenever you talk about the active element, the active element can be a voltage source, can be a current source. It can be, I am not sure about it, because that circuit will decide this element is behave like an active source or not. Okay, so we will discuss in a Telegrams theorem. Okay, and then we discuss some numericals on that on the basis of KCL and KVL. In a KVL, that it is working on the principle of conservation of energy, and we solve some numericals on that KCL and KVL and find it. And then we discuss about the series and parallel. What is the meaning of series? If one element after one other element is connected with a simple load, that is called series circuit. If two or more than two elements are connected with a pair of node, that is called parallel circuit. In series circuit, the current will be same and voltage will divide with every elements. In parallel circuit, voltage is same and current will divide. So I said that in the last class, I told that if you know parallel or series, you can solve 50% of that question of the network. If you define, okay, this is the series, this is series and this is parallel, because this will help you determine voltage and current. So we will continue this part. Today we will solve that last question. Okay, I hope you solve this question. In last class we discussed that some numericals and given this part. Okay, and given that this is your assignment. If you solve it, that is okay. If you don't know, so let's solve it, this question. So what is happening here? The current, that you have a voltage, you are determining voltage and current, and you have a circuit. So I am only prefer, okay, there is any series and parallel. Of course, this is showing is a parallel. If you know the voltage of this branch or this branch, you can decide the current. So I'm just saying that, okay, this given is 2 ampere current is going here. If 2 ampere is going through the 4 ohm, so this is voltage is plus minus 8 volt. I am writing plus minus. The current is entering in passive element, the resistor, capacitor, inductor. Always first that current entering, that is positive, leaving is negative. That is representation of the power absorbed. So this is plus minus and that is 8 volt. If this is 8 volt with this branch, so of course this is also parallel. If you are assuming this is the node, two or more than 2 elements are connected with pair of nodes, that is parallel. This is 8 volts, of course this is also 8 volt because they are in parallel. In parallel voltage is same. And this is 8 volt, of course this is also 8 volt and the same direction. So what amount the current is passing? 8 volt upon 1 ohm, that will be the current, that is 8 ampere. 2 ampere is given, and by this we can decide what is the voltage across the 4 ohm. If you know the voltage across this 4 ohm, you can decide what is the amount of current is passing through 1 ohm, because they are in parallel and in parallel voltage is same. And if you know the branch current of this, you can use a basic KCL. The entering current at this node is equal to leaving current. The entering current, let this is X. X current is entering towards this node and leaving current is 2 ampere and 8 ampere. The entering current is equal to X and leaving current is 2 ampere plus 8 ampere. 2 ampere and 8 ampere. So X become a 10. That is 10 ampere. So in a one line we can say that this X value is 10 ampere. If you know this, that 10 ampere, you can decide it what is the voltage. If 10 ampere is passing through this, if 10 ampere is passing through this, so this is plus and this is minus. And what is the voltage across 1 ohm? That is 10 volt. The first sign is positive, the second sign is negative, and this is 1 ohm. So 10 ampere is passing from left to right, so this is plus and minus, that is 10 into 1, that is 10 volt. If you know this voltage, if you know this branch voltage, you can define what is the voltage across 6 ohm. Because by the help of KVL, if this is Z1, this is Z2, this is Z3, you don't know about the Z1 voltage, but you know about the Z2 voltage and Z3 voltage, you can determine what is Z1 voltage. So I am assuming this is plus minus V6 and I am using this basic KVL in this loop. So minus V6, that is the first sign. This is first sign and this is first sign. I am always taking the first sign. Or you can take the minus to plus, that is increasing, that is plus V6. Plus to minus, that is decreasing, that is minus 10 volt. And plus to minus, that is decreasing, that is minus 8 volt. It depends on you. What are you doing for determining KVL? So just I am using the first sign is minus, I am writing minus V6, and the first sign of this voltage of this branch, that is 10 volt, and that is first sign is plus, so I am writing plus 10 volt. Of this branch the voltage is 8 volt and the first sign is plus, so I am writing plus 8. So V6 is what? V6 is 18 volt there. If you are following the slow, if you are following slowly now, you can solve any network there. Network numerically is just like a basic mathematics, 2 plus 2. Of course, we have some standard type of question when we go for the R equivalent where we are using star and delta. But if you are in a basic term and you will follow these type of understanding in analog circuit, of course we don't know all the values, but we know the branch current of this. I am starting from this point and we are going to this part. From this branch current only you will find out what is the voltage here, what is the voltage here, what is the voltage here. So that is the key. So in a network, whenever the network question is arises, one time that you will find any current or voltage across the branch and then you can solve it easily. Or if it is not given, so just figure out what is very easy to determine current and voltage across any branch. If you will find that any branch current, any voltage, you can solve all these questions, all these the circuit part. So till now we have a V6 that is 18 volt. Of course, if it is 18 volt, so what is the current? And I am using plus and minus, and this is positive. That means our direction is correct. If I am writing minus plus, it is minus 18. That means our direction is wrong. So it's up to you that you are writing plus minus or minus plus. This is just assume. I am just assuming plus minus. You can assume minus plus also. If you are using minus plus, that V6 become a minus 18. That means you are assuming wrong direction and just revert it, that is plus minus. If this is plus minus, that means the current is following from this and top to bottom. And what is that current? That 18 volt is here, 18 by 6, that is 3 ampere. The 3 ampere is passing through 6 ohm. If 3 ampere is passing through 6 ohm and here you have a 10 ampere, so what is this Y or what is this I? At this node, the entering current is I and leaving current is 3 ampere and leaving current is 10 ampere. I am just writing at the node of that I is equal to entering current is equal to 3 ampere plus 10 ampere. 3 ampere plus 10 ampere, that I become a 13. 13 ampere. Okay, once you solve this question, you will find the confidence. And if you are confident in this question, you will be perfectly solve the analog circuit. So just follow the basic fundas. Okay, that there is the 3 ampere. Okay, this is happening. Okay, this is 3 ampere. This I is what? That 3 plus 6, that 10 is 13 ampere there. And that by this only, by the solving of these method, you find it what is I, that is 13 ampere. If this is 13 ampere there, so what will be the value across this 1 ohm? The voltage across this 1 ohm, 13 into 1 ohm, that is 13 volt there. I am just using Ohm's law, KCL and KVL. Nothing nodal or mesh or any superposition or something like this. I am using a very basic, and of course we are not using superposition here because at least you require 2 sources. But I am not using a large concept. I am using a very basic, that Ohm's law, KCL and KVL only. And you know this voltage, if you know this branch voltage, if you know this branch voltage, you can determine what is V by the help of KVL. I am using a very basic KVL, that is minus V, that first sign is minus, the first sign is plus and the first sign is plus. So I am writing minus plus 13, and what is the voltage here? That is 18, V6 is 18 volt. So V become 31 volt. Yes, so this is the way you can solve that question. And at least try at your end. Okay, at least try at your end. Okay, what will be the value? Okay, let's solve that another question. So now we are going to start R equivalent. Okay, till now we discussed some Ohm's law, KCL and KVL. But today's topic is R equivalent. R equivalent is very important. Why? Because whenever you are solving analog circuit, you require a Z input. What is the input impedance of that circuit? What is the output impedance of this circuit? So where you are using a R equivalent, or you are talking about that RC circuit. In a RC circuit, you require a tau. Tau is what? Tau is basically R equivalent to C equivalent. You must require a R equivalent. So R equivalent, you help to decide it, oh, what is the total impedance happening across AB. What is the total impedance is occur across AB. So how can you figure out? By the help of series and parallel only. By the help of series and parallel, you can solve it. So I am just using, okay, you are trying to determine is what is RAB. You can use a voltage, let V across AB, that is V, and you are determining V by I. If you know V by I, you can determine is RAB, because RAB is what? Basically that V by I, that is RAB. Okay. So just think in this way, okay, that you have a current, and if you have this current is divided here with 3 and 6. And if you are looking this node, they are common in a pair of node. Two elements are connected. In pair of node, two or more than two elements are connected, they are in parallel. So I am saying that this is 3 ohm and this is 6 ohm. They are connected. So I can say that we can suppress this, and they are parallel impedance, so we can make a one impedance across it. How? Just I am saying that, okay, this is your impedance, that is 8 ohm, and these are the 3 and parallel of 6. Why? Because 3 and 6 are in parallel. And you solve that in a last class. Whenever you have a parallel, I use 1 by Z is equal to 1 by Z1 plus 1 plus upon Z2 plus 1 by Z3 plus dash. Like this. So if 3 and 6 are in parallel, I am saying that let this value is Z. So what is the meaning of Z? That Z is equal to 1 upon 3 plus 1 upon 6. That is equal to 6. If you are taking the LCM is 6. So 3 2 just 6 and 6 1 just 6. So what is Z? Z is equal to 6 by 3. That is 2 ohm. If you have a two impedance are in parallel, you can use a very basic method, that Z is Z1 into Z2 upon Z1 plus Z2 in a one line. If you have a two impedance are in parallel, Z1 into Z2 upon Z1 plus Z2, that is the value of 1 by Z1 plus 1 by Z2, 1 by Z is equal to, so you will solve it, that is Z1 Z2 upon Z1 plus Z2. And you just say that 3 into 6 is 18, 18 upon 9, that is 2 ohm, that is 2 ohm. But whenever you have a more than two elements are in parallel, so always prefer that 1 upon Z1 plus 1 upon Z2 plus 1 upon Z3 plus 1 upon Z4, something like this. If this is 3, 6 and let you have a 2 ohm, let you have a 5 ohm, let you have 15 ohm, like this. So always prefer 1 by 3 plus 1 by 6 plus 1 by 15 plus something like this. So this is the way you can solve it. So I can say that, okay, the 3 and 6 we can compensate, they are in parallel, so we can make that one impedance in place of 3 and 6, and that the value is 2 ohm there. These are the 2 ohm. If you are looking from this part, if you are looking from this path from A to B towards the A to B, that 8 ohm and 2 ohm are in series there. Or you are using that voltage source also, if you have a confusion that V and I, so that what is that V is equal to 8I plus 2I, so V upon I is equal to 10 ohm. Or you can write in a one line 8 and 2 are in series, so 8 plus 2 is 10 ohm. So if you are looking this question in a one line, let you have a metal one, you have a metal one, you have a metal one, and you solve these metal one, they have a 8 ohm and 3 ohm and 6 ohm, let 8 kilo ohm, 3 kilo ohm, 6 kilo ohm. So 3 kilo ohm and 6 kilo ohm become a 2 kilo ohm, and 2 kilo ohm, 8 kilo ohm are in series, that become a 10 kilo ohm. Okay, by this you can analyze, okay, what will be the overall impedance is happening and what will be the drop is happening is here. Okay, so this is the way, and you can define it. Okay, what is the R equivalent is happening through this across AB. Let's solve this question. Okay, we have another question. Take your time, just take your time, 2 minutes and solve it. Okay, can you solve this question? Okay, just analyze this question. You have a AB, across AB you are determining what is RAB. I am focusing on what is the R equivalent. R equivalent is very important. R equivalent or C equivalent, yeah, impedance equivalent. We will talk that. Now we have a discussing R equivalent. We will discuss about the C equivalent also. Just like this, in a Z terms, always represent in terms of Z. So whenever we are talking about this solution of impedance in terms of Laplace, we are representing Z is equal to R. If they are resistance, that Z is equal to R. If they are capacitor, I am writing 1 upon SC in terms of frequency, in terms of Laplace transform. And in terms of inductor, it is 1 upon, that is SL. You can write it 1 upon J omega C or J omega L. Okay. So you can think that this is Z1, Z2, Z3 and Z4, and you solve it in this way. Okay. So let you have this question. In this question, if you are looking this question, that this is A and this is B, if you are trying to find out what is RAB, basically you are trying to find out V upon I. I am not going for always V by I. Okay, I am just putting that node point. Okay, what is happening? This is A and this is B, so this is also B. This is B. This is also B. Okay, this is also B because there is no any element. This is B. Here is A. The element is present. Later I am saying that this is C. And this node is a principal node. This is not a simple node. That C point at the point where the 25 ohm, 180 ohm and 60 ohm, that three elements are connected at this node. This is not a simple node. This is a principal node, a node at which you have a more than two elements are connected. This is the simple node where 180 and 60 are connected. This is a simple node. And this is, if you are looking from C to B, they are in series. So always whenever you are solving R equivalent based question or Z equivalent based question, always figure out where is that principal node. At the principal node you find that the current will divide. Okay, I am taking that this is the node. I am not talking pair of node. This is a single node. And where you are talking about the simple node or principal node, this is a principal node there. Okay, so can we solve in this way that C to B you have a 180 and 60 and they are in series. So I can write in a way that this is 25 ohm, this is 180 ohm, this is 60 ohm, that in between C to B, this is C point, this is A point, this is B point, this is also B point. So in between C to B you have a 180 and 60. I am writing 180 and 60. And in between C to B you have a one more element, that is 60 ohm, that is connected like this. Of course, solve this question in a proper way. Okay, just convert the circuit where you can find that values. Maybe this question will be complicated for looking. Okay, it may be complicated to you, but just convert into a simple way that okay, this is a very simple way where you have a 180 and 60 are in series, that is 240, You can write it, this is 240, 240 and 60 are in parallel. So just I'm saying that okay, the value is like this, you have a 25 ohm, 180 and 60 are in series. So this is become a 240, because in series that impedance are adding Z1 plus Z2. This is Z. So Z is equal to Z1 plus Z2. Z1 is 180 ohm is 60 ohm. Z1 plus Z2 is 180 plus 60, it becomes 240. So this is 240 ohm. Now you have a parallel with a 60 ohm. And this is I think 25 ohm. Just check it, this is correct or not. This is 25 ohm. So now you have a point and you have a B point, and here you have a C. So this is B and this is B. In between CBU, they are in parallel, because C and B, two pair of node, in between two pair of node, they are in parallel. When you are looking from A to B, if you are looking from this branch only, you will find it okay that from looking from A to B, that C to B and C to B are in parallel. So 240 and 60 are in parallel. So you can solve that 240 into 60, because you have a two impedance only. So you just solve that basic funda, that Z1 into Z2 upon Z1 plus Z2. So this is 240 into 60 upon 300. This cancel out, and this is 48. Yes, that is 48. So this is 48 ohm. Yes, 240 into 60 upon 240 plus 60, 240 into 60 upon 300, because 240 plus 60 is 300. 0 is cancelled out, 3 2 just 6, that is 48 ohm. And now that 240 and 60 become 48, so the value is remaining that 25 ohm and 48 ohm. This is your RAB. Just solve it, that what is RAB, 25 plus 48 there. So this is the way you can solve that questions there, where you find it okay, they are just convert into a circuit in this form, where you will find in this way. So just I am solving this question in this, okay, that C to B are in series, that 240 and 60 are in parallel. Just solve this and it becomes 225 ohm plus that value, and that is 48. Okay, and that is 25 plus 40, it's 73. Yes, this is the way you can. Okay, let's talk another question. So by the help of series and parallel only I am solving one question, because you must have a basic understanding, okay, that if you have a series and parallel, how it will be help to you. Of course it will help you. We are trying to determine what is the current through 18 ohm, where you have a voltage that is 44 volt, and how we can solve it, because we don't know what the nodal or mesh. So by the help of Ohm's law, series, parallel, KCL and KVL only we will solve that question. Okay, let's solve this question. So I am saying that okay, this is that value. If they are in just a complex version, so just I am converting into that way, that is this is A and B, and then let this is C, and this is of course this is also B, because B and B is same, and I am writing this is D and this is E. Okay, so just I am converting this circuit in this form, that is this is 44 volt. In between AB you have 14.4 volt. In between AB you have a 22 ohm also. In between AB you have a 44 volt. In between AB you have a 22 ohm, just like this. And after that you have a 13 ohm as a resistance. That is this is A and this is B. Let this is C. I am just saying that this is C. C to B you have a 18 ohm. I am writing that C to B you have a 18 ohm. This is also B. This is also B. And now C to D you have a 11 ohm, and D to B you have a 14 ohm, and D to B you have a 9 and 4 ohm. Just solve that. The C to D you have a 11 ohm. This is the point of D. If you are talking about D to B you have a 14 ohm. D to B you have a 14 ohm, and D to B you have also that ohm. I am using this as a node, but D to B they are series. Why? Because there is no any current division, there is no other principal node. This is simple node, that 9 ohm and 5 ohm are connected in a simple node. So of course they are in series. So I am saying that the D to B, that 9 plus 5, that is 14 ohm, or you can write in this way, this is 9 ohm and this is 5 ohm. So this is 9 ohm and this is 5 ohm. This is the way. Just convert the circuit, the complex circuit, in a simple way by the help of nodal only, by the help of node point only. And this is B, this is also B, and this is E. If you are confused, where is E? That is D to B, in between 9 to 5 you have E, and 9 to 5 that they are in series. So if you are looking this circuit in a very simple way, this is a series circuit. And after this is series, this 14 and this 14 are in parallel. So I am not going in a very fast way. I am just solving in a very basic method. So this is 44 volt. This is 22 ohm. Resistance. This is 11 ohm. This is 14 ohm, and this is 14 ohm there. Just check it. Everything is correct or not? 44, 22, 13, 18, 11, 14 and 14 are in parallel. And if two impedance are in parallel, if two resistance are in parallel and that have a same value, that it become R by 2. How? That is basic, that if Z1 and Z2 are R, so R into R upon R plus R, that is 2R. This is become R by 2. Or any value, if you have any value that is R, it will be parallel 2 times, 3 times, 4 times, 5 times, n times, that will be R by n. So if R is 14 ohm and 14 ohm are in parallel, so 14 and 14 become what? That is 7, because 14 by 2. And if you have an equal impedance, that is 14, 14, 14, 14 in 5 times, so it becomes 14 by 5 there. So in a single line, I am just saying that this is 14 ohm, 14 ohm, they are equal. So I am just saying that, okay, this value is not present, and I am just saying that this become what? That is 7 ohm there, because they are in parallel. If they are in parallel, the value become a 7 ohm. And now if you are looking from this point, that 11 and 7 are in series. And you are determining what is the current I here, because this is I na. You are trying to determine what is the current through 18 ohm. So of course we are focusing what is the current through 18 ohm. Before that we are solving, because at least you solve that question, then it become a simple. Here it is very difficult to looking, okay, where we are trying to determine. Okay, so just solve in a simple way, and then you can determine, okay, what this is 11 ohm, this is 7 ohm, 11 and 7 are in series, so it become 18 ohm. So that I am just writing in this way. If you are comfortable with this, so in a one line I can write it. This is 18 ohm there. If you are comfortable, I am just putting that 9 and 5 are in series, so 14 and 14 become 7. 7 and 11 are in series, so it become a 18 ohm. So that is 18 ohm there. Okay. And if you are looking this point, 18 and 18 are in parallel. And in parallel, what is become is that value is same, so it become half. That is 9 ohm, and that is okay. But if this is 9 ohm, so what will happen? This is 14 volt, so this is also 14 volt because they are in parallel. Because I am trying to find out what is the current here. So this is 14 volt. We don't know what is the voltage here. We don't know what is the voltage here. If you know any one of that voltage, you can determine what is the current. Because in parallel voltage is same, in series current is same. So I am just switching this circuit in a way. This is 14 volt. This is the resistance, that is 22 ohm, I think. This is one of that impedance, this is one of that impedance, this is one of that impedance. That is 18 ohm and 18 ohm here. And you are trying to determine what is I here. And this is, I think this is 13 ohm. Just check it, this is correct or not. And of course this is 13 ohm. That is okay. So if you know the voltage across this branch, you can decide it what is the current, or you know the current. So what can we do? Here it is 14 volt, so this is also a 14 volt, 44 volt, sorry. And they are in parallel. So basically what is happening, I am just writing in this way. This is 44 volt, this is 13 ohm, sorry. This is 22 ohm. This is 13, and I am writing here this 18 and 18 become what? They are in parallel, it become 9. Yes. So can I say that okay, this is 14 volt, this is also 14 volt, 44 volt, this is also 44 volt, this is also 44 volt, that 13 and 9. Or you can use that defining the voltage, that is voltage divider. This is 44 volt, you can say that okay, this is 13 and 9. You can define it what is the voltage across it. Because both have a same current. What is V9? V9 is 44 into 9 upon 13 plus 9. In a one line, we are using a potential divider here, voltage divider. If the current is same for all the branches, you can use a potential divider. This 44 volt is same for 13 and 9 ohm, and the current will be same. So you can use a potential divider. And what is that value? 44 into 9 upon 22, that 22 and 20, that is 2 into 9, that is 18 volt there. And this 18 volt of the V9 of the 9 will be same for 18 and 18. Why? Because they are parallel. In parallel, voltage is same. So what is the voltage here? That is 18 volt, because they are in parallel. By this only you will find it. So if you have a 18 volt, what is the current? 18 upon 18, that is current is 1 ampere there. So this is also 1 ampere, this is also 1 ampere. So of course that current you have a 2 ampere. Just check it. 44 and plus 22, the current is 2 ampere. The 2 ampere is current is going here. The 2 ampere is current through 13 ohm, and after this in 18 ohm become a 1 ohm and 1 ohm. If you solve it, it become 9 ohm, but separately it is 1 ohm and 1 ohm only. This is the beauty of that question. Here I am not using any complex part, that is nodal and mesh. I am just using series, parallel, Ohm's law, KCL, KVL only. Okay. So just solve it. If you are good in network, it is a one line answer. You are using just 2 line or 3 line basically. Just what you will do, if you are good in network, just say that okay, this is the question. Okay, that 9 and 5 are in series. The 9 and 5 is 14, 14 and 14 become a 7, and 7 plus 1 is 11 is 18, and 18 and 18 become 9, and 9 and here is 22 are in parallel, that is 44, and 13 and 9 become 22. So of course that have a current, and we can determine what is the voltage here. So that is the way. So just analyze this part. If you are in BTech first year or second year, just solve in this way. If you are in BTech third year, don't solve in this way. Try to solve in a one line there. But if you are solving in a one line, you must require this part of analogy in your brain. In IIT professor, IIT Delhi professor is always saying that engineers is doing to reduce the complexity. What is the use of engineer? The engineers are working on that, how can we ease the problem. So you are just, if you are engineer, if you are engineer domain, you just solve the problem and make in a simple way. I am just doing this problem in a simple way, and this is also your goal. Just solve this problem in a simple way, and if you have a good level, you will solve in a 2 line or 3 line. If you are not good in network, just solve it, because this is the brain and this is the fundamental, this is your reference. After this you will stand just like metal stack. If you are in layout domain, you can understand metal stack. Okay, so just follow this part. Okay, let's try to another question. Okay, let's talk about this value, that find that RAB. Why I am using this type of question? Because you must have a basic analogy, how we can determine RAB, how can you determine what is R equivalent, and if you have a problem, you just solve it, because Z input and Z out, it is very important when you are go for the op-amp. If you are going for the op-amp, you always ask the question, what is the input impedance of that question, what is the output impedance, because input impedance and output impedance will affect your output response. The input will affect the loading. What is the meaning of loading? If you are interested in this, so let's talk about it. You have a CMOS inverter, and of course if the CMOS inverter is designed like this, you have a PMOS and you have a NMOS, and you have a input, you have output. This is the symbol, this is the circuit. Symbol is used in a digital domain and designing by the analog circuit designer. Here is the difference, that PD, the physical designer, will use this symbol, and this designed by the analog circuit designer. The standard cell team will design this CMOS inverter as per the requirement of the PD domain. The ASIC designer, the application specific integrated circuit designer, will design this CMOS inverter as per the requirement of that, because there is a requirement of propagation delay, there is a requirement of power dissipation, what will be the area, what is the threshold, what is the trip point. On the basis of the threshold, trip point, propagation delay power dissipation, on the basis of that you will design this CMOS inverter. And if you are designing this CMOS inverter, so what will happen? Okay, so if you are designing the CMOS inverter, so here you have a MOSFET as an input, and ideally the input current is 0. MOSFET, in a MOSFET the input impedance is 0, because this is a silicon dioxide. The representation of the symbol is separate. Why? Because this is silicon dioxide, this is not a conductor, this is insulator, so current cannot flow, the charge transportation is not present here. So the charge transportation is not possible. That means current cannot possible here. So the input impedance is 0. The input impedance is 0. What is that meaning? The meaning is that the input impedance is infinite. If the current is 0, what is that meaning? That input impedance is infinite. This is looking like an open circuit. Whenever you have an open circuit, current cannot flow. Because for current flowing, you must have a closed path. If that current can flow, the current is only flowing for a closed path. So if you are looking, if this inverter is connected with this, and you have a 0 and this have a 1, if there is some drop in an input side, of course it will have a less than that value. It will not have a 1, it will be less than that. If there is any drop, if there is any the current, so of course it have a voltage drop, there is have a loading effect. So once when you talk about the CMOS inverter, that's why in a CMOS inverter we are saying that the fan out is very good in a CMOS inverter. Why? Because the output of that first inverter will be same for all, because they are in parallel voltage is same and the input impedance is infinite, so there is no drop. So in a CMOS the fan out is very high. That's why we are using a CMOS logic there. We can design an inverter by the help of different ways. That common source amplifier is a one of that way you can design inverter. You can design a inverter by this only. What is the advantage if you are using this? The steady state power is 0. The output is going from high to low, that VDD to 0 means rail to rail. The fan out is very high. You can connect these part in a that is R equivalent only. So if you know that what is the input impedance of that, you can determine what is the voltage. The maximum voltage is here, their current is 0. So the voltage, the output of the first inverter will be same for all. Okay, so this is the way you can analyze. Okay, let's talk about this question. We have this question. In this question, we are determining what is RAB. The question can be any way. Just solve, just use a node. Okay, you have A. Okay, of course, this is A. This A is sorted with A. So this is also A. So if you are solving, and this is B. If you are making in a simple way, you have A, you have B. In between AB, you have A to A, you have 9 ohm. 5 and 4 are in series, and they are in a short circuit also, because this is also A. 5 and 4 are in series, that is 9, and in 9 you have a series that is short. So this is short. Of course, in a B Tech you studied about that current will always pass on a short circuit path. And you can think in this way, okay, that there is no impedance, there is no value. So what is the value of R? That is 0. 0 and 9 are in parallel. 0 into 9 upon 0 plus 9. 0. The impedance is 0. So if you have a 0 impedance, or always remember, if you have a parallel impedance, let you have that one concept is very important, that you have a impedance are in parallel, let you have R1, R2, R3 or any value, that R should be less than the smaller value, less than equal to the smaller value. R1, R2, R3, let this is 2 ohm, this is 3 ohm, this is 4 ohm. So that R will be a function of minimum. There it is happening. There is something wrong. Minimum of R1, R2 and R3. If you have a R1, R2, R3, that is any value, the R should be always less than or equal to the minimum value of that. So you have a 0 ohm, you have a 9 ohm. The value is 0 ohm, that equivalent is 0 here. Or you can write in this way that always current is passing through the short circuit path. So the current will not pass through 9 ohm, current is always passing through the 0 ohm. And then you have a to B, that is 6 ohm. So if you are looking this, there is no meaning of 9 ohm, I can eliminate this value. And this is only what, that A to B you have only a 6 ohm. So that RAB of this question is 6 ohm there. This is not something 9 and 5 or something like this. So whenever you have a short circuit path, that impedance is 0, the current will pass through that parallel circuit will be eliminated. In between 4 and 5, this is 9, and if they are in short, so there is no meaning of 4 and 5. That impedance only is RAB is 6 ohm. There is no meaning of 4 and 5. So by this you can make your concept in a short circuit path. By this question you can. Okay, solve this question where you have a and B. And in this A and B you will solve that what is RAB. So I am just writing in this way. You have a B here and you have a here. Of course, this A is connected with A here and this B is connected with B here. So if you are looking A and B, A to B you have a 2 ohm, A to B you have a 3 ohm, A to B you have a 6 ohm. There is no any short circuit path there. If you are using this path, that A to B is divided in the RAB. This is not sorting that 2 ohm and 3 ohm. Just think in this way. This sort is not, because this is connected with B. So this 2 ohm 3 ohm is not connected with a sort. They have a B node. So once you convert into RAB, this is A to B and A to B. That is 2 ohm, 3 ohm and 6 ohm. And just I am writing in this way ki always if the impedance is in parallel, the value should be less than or equal to a minimum value, that 2 ohm, 3 ohm, 6 ohm. If you don't have too much time to solve that question, if you have multiple type of question, always think in this way, the minimum value is happening. If you have a 4, 6, 3 or something like that, then just find out where is minimum value. It may be 2 or less than 2. So just find it what is RAB. So this is 1 by 2 plus 1 by 3 plus 1 by 6. So this is 6, this is 3, this is 2, this is 1. And just RAB is what? Oh, sorry. Where it is happening. Oh. 6 by 6, that is 1 ohm. Okay, so this is the way you can solve that question. Okay. Okay. Take your time and solve this question. Take your time and find out what is RAB. This is the question where you have a and B, and here you have a concept of sort. Just find out what is RAB. Just tell me what is that value there. I will put that value. or if you interested to determine what is the answer, you can just find it what is will be the answer. I am waiting for your answer. Okay, must be 1 ohm. Anyone else? Yes, please solve that question and find that what is that value of RAB. Okay, I am waiting. What is that value of RAB? Yes, anyone? No? Let's try this. This is A, so of course this is A. They are in sort. And if you are looking in this way, that means this is not sorted. This branch and this branch is not sorted. They are upper of that A is A and this B will be B. So A to B you have a 3 ohm, A to B you have 4 ohm, A to B you have a 12 ohm. 3 ohm, 4 ohm and 12 ohm. And by the looking of this question, by the looking of that value, I just say that the minimum value, the RAB should be less than or equal to 3. Less than or equal to 3. So whenever you have option is 4, 5, 6, 3 and something value, just find it. So what is RAB? That is 1 by 3 plus 1 by 4 plus 1 by 12. So this the LCM is 12. This is 4 plus 3 plus 1. 4, 3, 3, 4 are 12, 4, 3 are 12, 12, 1 are 12. And this is RAB is 12 by 8. That RAB is 12 by 8. That is 1.5. Okay, this is the way you can solve that question. Yes, anyone have an answer that 1.5? No? This 2 by 3, 2 by 3, 2 by 3. It is not 2 by 3. That RAB is 3 by 2 there. It's not 2 by 3. That answer would be 1 upon RAB is 2 by 3. RAB is 3 by 2. Okay? Okay, take this question. Just solve it. Okay, just interact that in this way. Okay, just tell me what will be the answer. Just solve it and find out what is the value of RAB. Take your time and solve that question. What is RAB? I am always asking RAB. I am not interested in 1 by RAB there. I am always interested and everyone is interested in RAB. So in this question also I am interested in RAB. Just tell me what will be the value of RAB. And the question is like this. Okay. So series and parallel is good and by the help of node you will solve it. But once you are entered in a typical question where the series and parallel node is not help to you, then I will use a star and delta. By the next class we will use a star and delta to star conversion, where you will solve and where you will have too much good questions. Because in every interview in a Texas in a Texas in a ST microelectronics, you will find these type of questions. Okay, when of course we have a MOSFET also, but if you have an analogy of the small signal model, you will find this type of R equivalent based question. So this will be a application of solving any other circuit. Okay, so must be you have a basic understanding and how you can solve that questions. So yes, anyone, that is 7 ohm, 7 ohm. Okay, let's solve it. What is that value? So 7 ohm name is what? That 7 ohm? Okay, I don't know that. Akash, someone, Akash is here, that is 7 ohm. Uh, okay, Naga is saying that. Uh, Praneeth, okay, someone is saying that. Okay, so let's try. So what is that value of RAB? Okay, so this is A and this is not A. Why? Because you have an element. This is B, this is not a B. Okay, because you have an element. Let's try this. This is C. Okay, I am just giving that. If it is not A and B, I am just saying that if this is C, so of course this will be a C there. So you have a, you have a B, you have a C. Just solve that in a simple way, that A to B, in between A to B, in between A to B, you have A to C, A to C. You have a 4 ohm, you have a 12 ohm in between A to C. So I am just saying that, okay, let this is point of C. A to C and A to C. A to C is 4 ohm, A to C is 12 ohm. So this is 4 ohm, this is 12 ohm. B to C and B to C. So of course I am saying that let this is also C here. B to C and B to C, that 6 ohm or 12 ohm, 6 ohm or 12 ohm. And I am just interested to determine what is RAB. Okay. So A to C, they are in parallel. 4 and 12 are in parallel. 6 and 12 are in parallel, because this is C, this is also C. So A to C, 4 are 12 and is parallel. So what can we write in a one line? 12 into 4, that is 48 upon 16. That is 3 ohm. Just 12 and 4 are in parallel. So 12 into 4, that is 48. 48 upon 16, that is 3 ohm. 6 ohm and 12 ohm. 12 into 6 is 72. 72 upon 8, that is 18. That is 4. That is 4 ohm. What is RAB? That RAB is 7 ohm there. That is correct. That is RAB 7 ohm. So this is the way you can solve that questions. So RAB 7 ohm. Okay, good. If you are solving, so that is very good. Okay, now let's talk about that capacitor. So I am not going in a too much, just I am writing in this way, okay, what is the meaning of capacitor? If you have a capacitor, so if capacitor are in parallel, let this is C1 and this is C2. So what is CAB? Okay, so what is CAB in terms of that? So as we know that 1 upon Z is equal to 1 upon Z1 plus 1 upon Z2. I am writing in this way now, in a parallel. Or in a capacitor, that Z is representing in terms of frequency, that is 1 upon SC. So if you are writing that is 1 upon SC is equal to 1 upon SC1 by the help of C1, and 1 upon SC2 by the help of C2. If you are looking in this way, though, this is just like a SC is equal to SC1 plus SC2, or you can say that C is equal to C1 plus C2. So whenever you have a capacitor and capacitor in parallel, so they will add. that will be add. That's C1 plus C2. Why? Because in an impedance that is 1 upon SC. In resistor that is R1 and R2 are in parallel, that is R1 R2 upon R1 plus R2. In inductor that is L1 and L2 they are in parallel because Z is equal to SL. That is just like a resistor, it will be L1 L2 upon L1 plus L2. But capacitor in a denominator, Z is equal to 1 upon SC. So in a parallel it will be add, that is C is equal to C1 plus C2. And when you talk about series, just like we have a two capacitor and you are talking about that A in bit AB, that this is C1 and this is C2. So what I am writing, that is Z is equal to Z1 plus Z2 in series. In capacitor, 1 upon SC is equal to 1 upon SC1 plus 1 upon SC2. That is 1 upon C is equal to 1 upon C1 plus 1 upon C2. So in a series, that capacitor is act like a parallel in a resistance. So once you have a capacitor in series, it will be act like a parallel in resistance. If they are in parallel, so it is act like a series in a resistance. So whenever you have a series, that will be 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus 1 upon C4. If they are in parallel, so you can just add it. So using these funda, and we will solve that one question. Okay, we have a to B. We are determining what is RA, that is CAB, and this is the question for you. So you have A and B. Of course, this node is different. So I am writing this is C. This is C. So this is also C. This is also C. And if you may be confused, so just you write it. Okay, that is X. Okay, that all are C. That X, X, and X. And just solve it in a simple way. So this is A to B. If you are talking about A to B, in between A to B you have a capacitor, that is CC. In between AB you have a capacitor, that is CC. In between A to X, you have a capacitor, that is CC and CS. So I am just writing, okay, in between A to X, let this is X. And in between A to X you have a two capacitor, that one is CC and one is CS. Just check it. A to X you have a CC, A to X you have a CX. CS and CC. Just like that, B to X, in between B to X you have a CS and CC. So in between B to X you have a like this, that is CC and CS. Just check it. So this is the node, there you have a X, in between A to X you have a CC and CS, in between B to X you have a CS and CC. If you are looking from A to X, CC and CS are in parallel. If you are looking B to X and CC and CS are in parallel. So we can write in this way, A to B you have a CC, CC and CS are in parallel. So I can write it, this is CC plus CS now. Why? Because they are in parallel. In parallel the capacitor will add. And B to X, that CS and CC R will add. That's CC and CS, because they are in parallel. And in between AB, this CC plus the CS and this CC plus DR, they are in series. So this will be what? If two impedance are same and in a capacitor they are in series, become by 2. In resistance become a 2Z. They are Cc and Cs, that is 1 upon Cc plus Cs plus 1 upon Cc plus Cs become a Cc plus Cs by 2. So I can write in this way. So this is Cc plus Cs by 2 and this is Cc. Just check it there. Cc plus Cs and Cc plus Cs are in series. It is act like a parallel in resistance, that is Cc plus Cs by 2 and this is Cc. And what is AB? They are in parallel. So what is CAB? CAB is Cc plus Cs by 2 plus Cc. So that's just a 3Cc plus Cs by 2. Just check it. This is correct or not? So this is the way you can solve these questions. Okay. Now you have a last question. Solve at your end. You have a and B. Determine it. What is CAB? What is CAB? This is an assignment for you. That C in between CAB, what is that value? Okay. So till now we discussed that R equivalent based question and we implement also to determine find the current in one of that questions. In the next class we talk about the star and delta and we will go for a complex numericals. Okay, without star and delta we will not solve it. We will not easily solve that question. So we will go for the star and delta. And then we go for that power analysis, Telegram's theorem, where that power absorbing is equal to power delivered. And then we go for the nodal and mesh. And then we start our theorems. So this is a large journey, but if you are going slowly now, you will be good in space. If you have a good knowledge of network, I am really sure you will analyze the circuit, you can design your own circuit. Because in analog circuit, you must have a basic understanding of how current is flowing in a circuit, how voltage is flowing, how resistor and capacitor, diode, MOSFET is working, where we can use a diode, where we can use a Zener diode, where we can use a MOSFET, where we can use a fixed resistor. If you know these components feasibility and properly and how it will be effect in your circuit, you can design any circuit here. I am really sure about it. So for now, that is okay. Thank you so much. And of course, happy Holi there.